My name is Konstantin Hüdepol. I'm a product manager at Softing, looking after handheld test products, and I have a colleague with me, Ada Kujoglu. He will look after the chat today.
Exactly. Just so that you see me as well. Yeah, I will be answering your questions on this chat and questions tab. If you have any questions, just type them in. Otherwise, we will try to answer them also at the end of the session.
Very good, thank you. So again, very warm welcome to our seminar today, another episode of our long series of online seminars. Today we're going to talk about single pair. You might say, well, single pair is actually a really old story. Analog telephone is single pair, that's nothing new. Well, actually, what I'm going to talk today is very new. It's single pair on Ethernet single pair technology. And this presentation will take a quick look on single pair cabling as such. Then we're going to talk about applications for single pair Ethernet. We're going to talk about the IEEE standards and ISO-IEC standards. And for us, from IT networks point of view, most interesting, of course, is the measurement standards, because our testers will need to measure those new cables. And then I'll give you an insight of the current status where we are on measurement standards, and will give you also an outlook on what's going to happen in the following months and so on. So before we actually dive into technology, we'll have a quick look at Softing for those who don't know Softing yet. Softing is a holding company. We are based outside of Munich in a town called Haar. We have been founded in 1979. We have about 90 million euros turnover. We went public in 2001, and we have around 400 employees. So it's a mid-sized company. We have 3 business units. The colleagues at automotive, they do software and hardware for control systems for vehicles, so cars and trucks and so on. The guys at industrial, our colleagues in industrial, they develop software and hardware for industrial automation. And us at IT networks, basically, we build measurement devices for IT networks, so verification, qualification, certification of copper and fiber cabling in IT systems, basically. Quick glance on our product portfolio. We have copper and fiber certifiers, network infrastructure cabling speed certifiers, speed testers, cable wiring testers, trackers, gigabit network analyzers, and also wireless LAN products. So it's a quite wide range of handheld test products. That was the small commercial block. We are based around the globe. We have 4 offices in Europe, 5 offices, sorry, Munich, Vienna, Milano, Paris, London. We have a subsidiary in Shanghai, China. Most of our test devices are developed in Singapore, and we also have a strong US presence in Knoxville, Tennessee. So you can see it's a company nowadays. So let's go and have a look at single pair Ethernet. So what is that? Well, the original Ethernet started with 2 pairs, 10 megabit, 100 megabit Ethernet. You had 1 pair transmitting in one direction, the other pair transmitting in the other direction. So and then when speeds went higher, 1 gigabit and 10 gigabit, the cabling was extended to 4 pair transmissions, so and 4 pairs in both directions. So every pair did transmit and receive, basically. And now single pair Ethernet is basically 1 pair transmitting in both directions. And for LAN and industrial applications, speeds range from 10 megabit to 1 gigabit. We come into into more details later on. So that is basically the principle. The target is operate various Ethernet speeds and Ethernet applications on 1 pair of cable with 1 protocol, Ethernet. Very simple. we have miscellaneous applications and technologies. And if you want to learn more about that, I would encourage you to look at this website, Single Pair Ethernet. It's a Single Pair Ethernet partner network where Softing is a founding member of. You can learn on this website quite a bit later on also on this topic. Basically, Ethernet is a whole ecosystem. The T1, SPE T1 technology, there is connectivity, cables, protocols, cabling standards, test standards will come, and remote powering, similar to PoE, will happen here in standards. Then we have many different components, PHYs, magnetics, connectors, cables, patch cords, accessories, test products should be in here, plugs, connect, everything. It's going to be a whole universe of hardware you supporting gigabit Ethernet, Single Pair Ethernet. With that, you can connect to many different devices, human interface, monitors, switches, sensors, CAD controls, edge computers, actuators, tools for it, and testing products. With this, you can serve many different industries: robotics, machines, smart factory, controls, energy, all kinds of different applications. And that makes it a very interesting field for us as well, because all these fields will need some kind of testing, of course. Applications, it all started actually with the automotive industry. In the automotive industry, they were looking for very lightweight, small diameter cables for vehicles up to 15 and 40 meters. 15 is basically cars, 40 meters is things like trucks. So they looked around for a common style cabling, and if you go on a single pair cabling, the advantage is you get a very thin, small cable with you can always use the same components, and with Ethernet you have always the same protocol basically. These guys in automotive, they need speeds up to 5 and 10 gigabit per second. But a modern vehicle is almost a small rolling data center with many different sensors, radar sensors, cameras, and so on, that produce an enormous amount of data. This application for us from a measurement point of view is not so interesting. We are not, in this presentation, we will not cover that. We will cover structured cabling. Also in structured cable, we have numerous different ranges or length ranges up to 1 kilometer actually, and up speeds from 10 megabit to 1 gigabit per second today. That's going to change, but today that's what it is. So 1 kilometer Ethernet, that sounds very interesting for many different applications. Keep in mind, Ethernet up to now in structured cabling was only up to 100 meters. All right, so what applications actually are we looking at? Possible applications are sensors and actuators. 10 megabit over 1 kilometer distance, that can replace many different older protocols. Ethernet can become here, or will become here, the common transmission protocol. That is very interesting in the industry, because up to now there are many different protocols. So if you need to if you need to extend something in a current industry environment, you always have to take care that the devices cover the right protocol, that it's compatible to other devices, and so on. If you use Ethernet, it's all Ethernet, it's all compatible, at least from a protocol point of view. The other thing is control and monitoring. That is interesting in factory automation, for example, up to 1 gigabit over 40 meters, 100 megabit or 1 gigabit over 15 meters. And again, also 10 megabit over 1 kilometer today. All that up to today is covered by some IEEE standards, IEEE 802.3. You have the CH, 802.3 CH, that covers the automotive applications, 2.55 and 10 gigabit. Then we have the 802.3 BP, also called 1000 base T1, 1000 megabit over short lengths, 40 meters shielded, 15 meters unshielded. 802.3 BW, 100 base T1, 100 megabits per second, again 40 and 15 meters, 40 meters shielded, 50 meters unshielded. And the 802.3 CG, the 10 base T1L, 1L for the long range, 10 megabit over 1000 meters. I'll talk about the 1500 meters in a second. And the 10 base T1S for short range, 10 megabit of over 15 meters, unshielded. The long range, 1 kilometer, is a point-to-point connection, and the 15 meter is a point-to-multipoint. So you can connect several devices to one cable. So that is actually, we are back to a bus structure here. Current cabling supports 1000 meters, and there's of course wishes to extend these 1000 meters. There's already people saying that 1000 meters actually is not enough. All right. We're gonna also, there's also a standard for remote powering. It's not PoE, it's PODL, POODLE, power over data line. It's basically, it can support 10 classes up to 50 watts. You can see the classes down here. We don't read all of them, but basically you can driving 50 watts of power over one pair of cable. The way POODLE is supported is different than PoE. In PoE, the Ethernet signal is coupled through inductors, basically, and in single pair Ethernet, Ethernet is coupled through capacitors, so that you see that the power then is connected very differently. Sorry for this disturbing noise here. That's my let's talk about cabling standards. Cabling is defined in the ISO IEC ST46C group. There are definitions for cables up to 20 megahertz and 600 megahertz. And my mouse doesn't want to connect to go further anymore. Sorry about that. We have a little IT issue with my computer at the moment. Sorry. Okay, back again. Connectors are defined in the SC48 group. There is the 63171 range of connectors. The 63171-6 connector is the preferred connector in ISO 11801, in the amendment, I should say, of ISO 11801-1. There's a draft for that currently under development. And the -6 connector is the preferred connector for MICE3 environments, and the -1 connector is the preferred connector for MICE1 environments. MICE we're going to talk about a little bit in a moment. MICE1 basically means office environment use, so very low specifications in terms of electromagnetic resistance, interference, and those things. MICE3 basically is heavy industry. And you read exactly right here. It's an LC mating interface. So LC, lots of people know from fiber optic cabling, and now we're going to have an LC style connector for copper cabling with two pins inside there. So the reason for that is because LC is very small footprint connector, and all the patch panels and so on with base for the LC bulkheads already exist, so it's very easy to reuse those patch panels and so on. See also the SPE partner network again for a little bit more information on that. Then there are other connectors as well that can do single pair. One, you know, since many years, the Terra connector has since many years and options for just one pair patch cables, for example. And there's also another connector here, the IC63171 is also -5, which is also a single pair connector, which is in ISO 11801, the alternative connector. And there will be also connectors like an M8 hybrid. M8 is a 4-pair connector, 1 pair for data, 2-pair connector, 1 pair for data and 1 pair for power. And you notice here power up to 20 watts or 400 watts. That's much more than the power over data line will support with 50 watts. So that is for really power hungry devices, basically. That's about connectors. Now let's have a look at cabling and component standards. There's a technical report, ISO ICTR 11801-9906, that covers some of the IEEE standards that are already published, which are these 3 standards basically, except the 50-meter one. You remember the 50-meter one is with this bus structure. So this is not covered yet. And also the automotive applications are not covered in here. But basically the main ones, the short range, higher speed and the long range 10 megabit basically is already covered in this technical report. And you know, ISO always wants to give cabling a generic roadmap, basically. So ISO, the new amendment of ISO 11801, Amendment 1 will cover a generic set of classes for cabling. So the T1A classes basically cover a frequency range from 0.1 to 20 megahertz and with different lengths. So the A100 is 100 meter, the A250 is 250 meter, and so on. Additionally to that, there will be a class T1B with a frequency range of 0.1 to 600 megahertz. And you notice there's no limit length, minimum length supported. And in future also T1C with 1 to 1250 megahertz. Also to be noted, at the moment there's no Senelec EN project for that right now, but I'm pretty sure that Senelec will add that at some point as well. So that is something which is under development right now. The drafts for that become pretty stable now. And if you look at that, at these several classes here, they can have a number of connectors. The T1A 1000 can have up to 10 connectors in between. Why do you need so many connectors? Imagine that is a 1 kilometer cable here. So in a 1 kilometer cable, it's very likely that you have to pass through several building walls or machine walls, or you have to go through different borders basically. So to enable that, the definition has been added for up to 10 connectors. The T1A 400 will have 5 connectors, and the other ones will have 4 connectors in that channel. Also to be noted here, it's this, as I said already, this is still a draft standard. It's not finished yet, and there are a couple of things that are still to be defined. Like, for example, the minimum frequency for where pass-fail starts basically is not yet really defined. So that there's discussion in, for example, at the T1A 1000 that starts at 0.1 megahertz. Will pass-fail really start at 0.1 megahertz, or should pass-fail, for example, start at around 2 megahertz? That is still under discussion. It's not quite finished yet, but that's only a matter of a couple of more months until that questions will be answered. Yeah, so now the real interesting part from a testing point of view is the measurement standards, of course. If you remember, our testers, the certifiers, they work according to ISO IC 61935-1 for installed permanent link and channel measurements, installed cabling. There is another standard, the -2 for patch cables. So this standard defines patch cables. The 14763-4 defines testing of end-to-end links. And all these above standards, they define all the DC and RF radio frequency measurement parameters like next, return loss, insertion loss, ACRN, and so forth. They contain measurement methods for field and laboratory, so for both. They define the accuracy classes for testers. That is very important for testers because we have to prove and have to measure against a certain accuracy range. And also for us, as a tester manufacturer, very important, the error models. We have to calculate the maximum errors we can have, for example, in a crosstalk or insertion loss or return loss measurement. This standard is very extensive, 120 some pages. However, it has one shortfall. It doesn't cover single pair. So what the ISO IC now is actually starting right now is a new measurement project for single pair Ethernet. It's going to be the 61935-4. There's a first working draft at the moment in preparation, and we expect to issue this first working draft as a new work item proposal to IC now in autumn, probably in November this year. I'm a member of that working group, so we are at the moment pretty heavily developing this first working draft. The publication for that, I would expect in about 2 years. IEC is not very fast. It's a slow working progress, but it usually takes around 2 years to develop such a standard. Right. So if you compare 2 pair and 2 and 4 pair measurements with a 1 pair measurement, there are things that are very similar. For example, wire map. Yeah, you need to do a wire map. It's less wires, yes, but you need to at least show prove that the 1 pair and optional shield is there. DC loop resistance measurement is an important measurement. We kind of do that on 2 pairs, on 1 pair as well. If you remember a previous webinar we did on DC resistance unbalance, that's a new measurement for 2 and 4 pair cabling. That is really important for high power PoE, 4 pair PoE applications up to 90 watts. That this measurement basically measures not only the loop resistance of a cable, but also single wire resistance. There's discussions right now in standards if that is really important for single pair as well. And there's a technical hurdle in there. If you only have an unshielded cable, just one, you cannot measure DC resistance unbalance because you need a return path basically. In laboratory, that's of course possible because both sides of the cable are on the same desk and you can measure that. But imagine a 1 kilometer cable, you cannot connect on the same wire, which is where the other end is 1 kilometer away. That just doesn't work. So there's some technical discussions going on and also some discussions if that measurement is really necessary or not. Insertion loss, important parameter, and return loss. Near and crosstalk and all the measurements that are related to crosstalk, attenuation, ACR, attenuation to crosstalk ratio near end, and attenuation to crosstalk far end, cannot be measured on a single pair cable. There is no crosstalk, so they go away. Then all the power sum values from next and ACRN and so on, also are irrelevant because there is no crosstalk. Very simple. But there is some crosstalk in single pair cable, alien crosstalk. If you have bundles of cables, you have to take care about alien crosstalk as well. So that's going to be a parameter we're going to look at on a later slide. Then you have things like transfer conversion loss, TCL. TCL is similar to a return loss measurement, but TCL measures the reflected common mode of a signal, not the differential mode. And it actually only is really applicable to UTP cabling. There's long discussions and heavy discussions going on what to do about that on shielded cables. For shielded cables, coupling attenuation is very interesting measurement, but coupling attenuation basically is only feasible in laboratories because you need very, very extensive and very expensive measurement equipment for that. Sorry. Coupling attenuation basically measures the immunity of cable against electromagnetic interference. So on these two, TCL and coupling attenuation, there are big question marks what we actually need to do about that for single pair cabling. So alien crosstalk, we just talked about that already. If some of you might remember that picture from the normal 4-pair cabling, the 6 around 1. You have 6 disturbers here that influence the red one, the disturbed cable. So they send a lot of disturbing signals to that one cable in the middle. Imagine if you have a cable tray like that with many bundles of cables, you can imagine how much crosstalk is going on between cables. So that we need to define testing strategies for that and testing methods for that. And there is also some crosstalk between pairs in a 1-pair cabling. There's an interesting application. You could go with a 4-pair cable to a consolidation point, and from that consolidation point, 1 pair to devices. So within the 4-pair cable, you have crosstalk again. It's not normal crosstalk, it's a kind of alien crosstalk. So we have to develop also testing methods for that. Another issue is frequency range. The current 61935-1 standard covers frequency range from 1 MHz to 2000 MHz. Single pair needs frequencies from 0.1 to 600 MHz and in future up to 1250 MHz. So the new standard must cover this new range. The accuracy levels don't fit anymore. The old IC 61935-1, they have several accuracy classes covering basically the classes of cable that need to be measured. That doesn't fit anymore to single pair cabling. So also there we have to define new accuracy classes and the new frequency range. We also need to take a little look at, are the channel and permanent link mathematical models still valid for that? And we have to look at error models because we have a new frequency range and potentially also different methods how we, for example, measure alien crosstalk, things like that. So we need to verify that all the error models still apply to these new field of testers. Okay, so earlier we have talked about mice. For those who don't know, mice is a definition for the mechanical, ingress, chemical, and electromagnetic properties of cabling. With that one, you can define what properties the whole cabling, including cables, connectors, patch cables, everything needs to have. As I said before, a MICE 1 environment is an office use, so there's no water tightness, there's basically no dust tightness, no really heavy specifications for electromagnetic interference. Sorry, and in MICE3 environments, basically you have very tough conditions. Things have to be watertight or oil tight, very heavy electromagnetic interferences, and so on. So for heavy industry, we have to really look at the E3 part, which is the electromagnetic interference part. Imagine you have a small cable, like a single pair cable, running besides a very large electric motor or a welding machine or so. This motor sends out a lot of electromagnetic noise and disturbs the Ethernet signals in the cable. So we have to find a measurement method to make these to validate if these cables actually can work in that environment. In laboratories, that is feasible with coupling attenuation measurements. You're going to see that down here on the bottom. That is a measurement for coupling attenuation in the laboratory. So the blue tube here is basically a sensor. It's a current clamp, basically, and you run a piece of cable inside that clamp. And on the bottom there, you have a spectrum analyzer, basically worth 80,000–90,000 euros. So you can imagine that's not quite what you would like to have as a handheld tester. Up to now, basically standards say if coupling attenuation performance can be proved in the laboratory, it doesn't have to be measured in the field. There are discussions going on right now if that still holds up for industrial environments, really, or if there's something else as will be needed, basically. So now we come to the outlook. What's going to happen next in standards? So you remember that table from earlier slides. Well, the BP with 1 gigabit is nice, but it's only 1 gigabit. So people already say, well, we also want 5 and 10 gigabit. 40 meters and 15 meters is an okay distance, but actually it's a little bit short. I mean, people want to have 100 meters or more. The 100 megabit standard also is only 40–50 meters. The CG, the 10 base T1L, basically with 1,000 meters is nice, but people say it should be minimum 1,500 meters. So you see, there will be additional work needs to be done in these standards to extend reach, to make things faster, and so on. So that's going to be interesting from a standards development point of view. Outlook on measurements. Well, the frequency ranges, they are kind of defined now. We go from 0.1 to 600 megahertz and 1250 in future. But what's not so really defined there is the steps you need to test. How many frequency steps do you really need to test? We need to define accuracy classes and error models, and to do the reference model. So for each type of measurement, like permanent link measurement, there's a reference model how to do that. That actually is pretty simple. We can do all these things, relatively simple work. Then there's a section which is a bit more complex. We have to adapt the alien crosstalk measurements in cables or in a multi-pair cable, and also measurements on patch cables need to be defined. There's going to be patch cables for that around. And of course, the still open question, how to really deal with MICE2 and MICE3 environments with heavy electromagnetic interference problems. That's still an open field where there's going to be a lot of discussions in the next months. So we are Softing, we are working quite hard in that development. We have since November 2019 showed the first prototype for a single pair measurement with the 63171-6 components. That's these components that are will be the preferred components in the amendment of 11801. This setup we have shown in as prototypes and also have here on display is suitable for 1 pair measurement, but also for 4 times 1 pair measurement for alien crosstalk. So we do also some alien crosstalk tests with these. If you look at closer, it has 4 ports, single pair. We also will offer, of course, just a 1-port version of that. So for normal measurements, you don't need that bulky thing there. You can use just a normal 1-port cable. And of course, very interesting also for some applications, the M8 hybrid, where we also already have prototypes for those. So we are quite interested in that field. We are heavily involved in standards in that and in the development with cable manufacturers to develop suitable measurement adaptation for that. That's how a measurement looks like. The wire map, yeah, it's a bit boring, only 2 wires and a shield. Not so much going on there, but still we have to measure that. By the way, that is that example is a T1B cabling, so up to 600 megahertz in that case. If you look more into details, the resistance values, insertion loss values, return loss, that is the insertion loss measurement. In that case, we have measured it up to 2 gigahertz just to show the capabilities of the cable. The T1B only actually goes to 600 megahertz. So the measurement, the limit really stopped here, but we just wanted to show what else is going on here. And of course, return loss measurements. Also, what you can see here is that the samples we have measured have actually pretty good margins and pretty stable results. In reports, the report is also relatively short because it up to now only includes the insertion loss and return loss measurements. Simple thing. That basically brings me to the end of the presentation. I would like to draw your attention also to the other seminars we do. We have quite a long list of seminars on our website. Some of them we already have performed, so you can view recorded sessions of those. We also have a winter promotion, autumn-winter promotion going on. The savings book, take a look at that. Maybe there's something interesting for you. And also look at our YouTube channels, because we have quite a number of useful videos on our YouTube channel. So thank you very much for going with me through this presentation. And now let's look at the questions. Do we have questions now?
Yeah, we do have some questions. Let's start with the first one. Do I need a new cable, or can I use existing ones and split them?
That's an extremely good question. There will be new cables for that, especially the long range, the 1 kilometer application. You will need an AWG-18 cable. So normal LAN cables, the thickest diameter you use is AWG-22, and this one is an AWG-18. So it almost looks like a power cable. The other ones, the cables up to 600 megahertz, they also need to go down to 0.1 megahertz. So I would recommend to look at the specs of the cables you usually use, talk with your cabling manufacturer, and get recommendations from your cabling manufacturer.
Are these the similar ones, or?
The sample I have here is a T1B cable from 0.1 to 600 megahertz. We have used that for evaluating our prototype adapters, basically, and that's also what we use with some of the cable manufacturers.
All right. Okay, so I have 2 more questions here, but I see, I think you answered already some of them, like, does PoE work on single pair Ethernet? You talked about PODL.
Yeah. So PoE and PODL is not compatible to each other. There's different classes and a different way to transmit power, so it's incompatible.
Are there also already some active components for Podel as well? They're gonna be in the future, maybe.
Yes, you will see some coming up in the market now. Podel is around since, I believe, 2018 already. So,
Okay.
it's only a matter of time, I would say. And watch the space.
Okay.
Yeah.
And the third one, also something that you already answered, I guess. What's the highest speed you can reach on single pair Ethernet? You talked about like different length.
Yeah. So the highest speed on structured cabling is currently 1 gigabit. That is sufficient for automation purposes, for cameras and so on. But there's also plans to extend that to multi-gigabit. And if you remember, there's this class T1C up to 1250 megahertz that will support speeds beyond 1 gigabit in future.
Right. I think these are all questions that we received.
Okay.
You can always ask your questions. You can write us an email or go to our website for more information, I guess.
Yes. And also take a look at our website for the other presentations we have. Some of them are already on video. And with that last words, I would like to thank you very much for attending the webinar.
Oh, wait, we have one more question. Actually.
One more question, cool.
Yes.
Go ahead.
Who is using SPE cabling?
Who is using that?
So the application, like
the application. Maybe I go back. If you bear with me a second, I go back to the slide with the applications, because that explains it quite nicely. Sorry, that takes a moment, but my computer with GoToMeeting is not the fastest one in the world. See if I can go back here quicker, because that slide really shows. Oh, come on, it's slow.
Yeah.
I think was it that one or the next one? That really explains it quite nicely. Come on, here it is. That's what I wanted to show. Who is it? There's not the one customer group that can use single pair Ethernet. The main use for the time being will be industrial automation, where you can remote control devices on sensors, especially for the sensor industry. Imagine 1 kilometer with Poodle, so with remote powering sensors that are kilometer away and addressing them with Ethernet is a very interesting application. Robots with more high-speed applications basically is very interesting. You see up here windmills, windmills from the top down, the tower down to the ground level of the windmill. It's usually quite a long distance cabling. That would be a nice application. So many different applications that actually look up could be interesting for single pair Ethernet. So it's a whole ecosystem, really.
Yeah, thank you. I think that was the last question that we've got.
Okay, cool, good. So with that, I would like to thank you again for attending the meeting, and stay tuned. I would like to welcome you again on one of our next meetings. Thank you. Goodbye.
Thank you. Bye.